So as we saw last week in the graphing motion, also known as the acceleration lab, we've seen motion graphs that can show three different things: position, velocity, and acceleration. This video, part one, will cover position and velocity. So on the right side here, I've got just some notes for us about position graphs and velocity graphs, some different things that you will see in the graph that we're about to go over. So a position graph is also known as a direction graph or a distance graph. It's kind of those three different words: position, distance, and direction, all kind of work together when we're talking about a position graph. So this was the first graph that we worked on in that lab. Obviously this one looks, what I've got over here on the right here, looks a little bit different than what we saw in lab. This says a position or velocity, meters per second, of a person walking, and the y-axis has both position and velocity. The reason I did that is so that we could look at this one graph and use it for two things: use it for position or use it for velocity. As you can see on the bottom, we have time in seconds. So what we're seeing is that if we're looking at this as a position graph, at second one, what you want to do is look at where you are on the y-axis. So we are right here, which corresponds to 5 meters. So we are 5 meters away from the motion sensor. Second 2, we are still at 5. Second 3, we are still at 5. Okay, so what did we do between seconds 1 and 3? Between seconds 1 and 3, you stood at 5 meters. You didn't do anything. Really, you were standing around. Between seconds 3 and 4, now let's look at that. At 4, you were at 0 meters. So between seconds 0 and 4, right here, you walked from 5 meters, so you moved from 5 meters to 4 meters. So really, all we need to do is we need to look at the time on the x-axis here and then see what it's telling us on the y-axis. So 4, 5, and 6 are all the same. You're standing at 0 meters. Now we see some movement again. 7, 8, and 9, the whole time we are over here at 3 meters. So that means that between seconds 6 and 7, right here in this time, we moved, right? Moved from 0 meters to 3 meters away from the motion sensor. Then we stood here at 3 meters. Again, we're obviously moving again to a new position. Now this is one interesting that we didn't see in the lab. So seconds 10, 11, and 12 were all at the same spot, and that same spot is, -1. So by -1, how is that possible with your position? What that would mean, if 0 is the motion sensor, -1 would be behind the motion sensor, a meter behind the motion sensor. So that would only work if you had a two-way motion sensor. We don't have two-way motion sensors like that. That would actually be pretty hard, because if anybody walked either in front or behind the motion sensor, it would pick up that distance. But that's just something interesting that I wanted to throw in there. So over here is kind of your cheat sheet. It says the x-axis is time, your y-axis is distance, or your position in meters. If your graph goes up, you're moving away from the motion sensor. If the graph goes down, you're moving towards the motion sensor. Right here, we're moving from 5 meters away to 0. Here, the graph is going up. We're moving away from 0 to 3. Flat line, it means you're standing still. 0 is standing at the motion sensor, right? So right here, you're standing right against the motion sensor. And then possible go negative only if you had a two-way motion sensor and walked past it. So now I'm erasing all of this so that we can take a look at the next option. The next option is, that took a little bit, velocity graphs. So a velocity graph works much the same way. But rather than looking at your position, you need to look at how fast you're moving, right? Velocity, another word for velocity is speed, right? But it's speed with a direction. So this is going to tell us two things. So first of all, let's just focus on this time right here, okay? An easy thing to do is just kind of divide the graph up into segments, right? We can be like, okay, these are all different segments that we're looking at, right? So this segment here, between seconds 1, 2, and 3, we're doing the same thing. What are we doing? Well, we're at 5. Now, does that mean we're at 5 meters? No. Right now, we're focusing on this as a velocity graph. So that means we are moving this whole time. You're no longer standing still. You're moving at a constant speed. You're moving at 5 meters per second. So in this case, if the line goes down, it means you're slowing down. You're going from 5 meters per second down to 0 meters per second. So you slow from 5 to 0 meters per second. Once again, it's flatlining. It doesn't necessarily mean you're not moving. It means you're moving at constant speed. In this case, that constant speed is 0, so you are not moving from seconds 4 to 5. Line goes up, you're speeding up. Speed up from 0 to 3 meters per second. Okay, so now in this area, if the line's going down, graph goes down, you go slower. So this means we slow down, and we can slow from 3 meters down to, -1 meters per second. Slow 3 to -1 meters per second. We're going to talk about -1 meters per second in just a moment. And here from 10, 11, and 12, we are continuing to move at -1 meters per second. So what's up with this -1 meters per second? What that actually is telling us, and the lab asked us to play around with that, if you're moving at -1 meters per second, you are no longer moving away from the motion sensor at 1 meter per second. You are actually now moving towards the motion sensor at 1 meter per second. So if we're moving at -1 meters per second, that means that we change direction. And we changed from going away to going towards. Away to towards the motion sensor. So in this time here, we are moving 3 meters per second, which is really fast, 3 meters per second away from the motion sensor. We then slow down to 0 meters per second, right? So we stop moving, and then we actually start moving again to 1 meters per second back at the motion sensor. So we are moving at 3 meters per second, we slow down, we stop, and then we reverse directions and go back towards the motion sensor. So remember, velocity is not just speed, but it's speed with a direction. So if it's negative, that means that we're moving towards the motion sensor. So something I want to call your attention to is that I just changed G. When I had initially written this up, I had forgotten that these motion sensors do detect velocity, not just speed. So I had written that it can't be negative. That's not true. It can be negative because it's velocity, which is speed and direction. So see, even Mr. Kalman messes up. And negative means that you are moving towards the motion sensor. So I fixed it to show that. So if you were looking at it previously and then noticed how it just switched, it's because I caught my mistake and wanted to change it here. So if it's negative, it means that it has changed direction. You might be moving at -100 meters per second, which I know is super fast, but that would just mean that you're moving at the motion sensor. If you then change directions and start running away from the motion sensor, it might spike all the way up to positive 100 meters per second, which tells us that you're now running really, really, really fast away from the motion sensor. So positive or negative, positive or negative indicates direction. So the velocity graphs are almost a combination of the position and a speed graph all in one. Please let me know if you've got any questions. This should help for just kind of understanding the basics of position and velocity graphs. Acceleration is going to be a little bit more difficult, so I wanted to get this topic down, and then there will be a follow-up video about acceleration graphs in a little bit. This will be the first topic on the quiz or anything else, so I wanted to get this one out. And we'll cover acceleration in its own video where we can focus just on that. Hope this was helpful.